Aloha e kako! Welcome back to the Neb Hapakahana Online Professional Development for our 7th grade curriculum. Let's take care of the lo'i. In this video, we'll be covering Unit 5, Statistics. Here are the Common Core standards that will be covered in this unit. Please feel free to pause this video if you would like to read them more thoroughly. If you have a copy of our curriculum, you'll be able to find all of these standards at the very beginning of the unit. The standards in this unit come from the Common Core domain of statistics and probability, as denoted by the letters SP. Of the standards in this domain, the statistical ones will be focused on in this unit, and the probability ones will be focused on in the next unit. Unlike the statistical standards of grade 6, which primarily focus on depicting the center, the spread, and the shape of statistical data, the 7th grade standards instead focus on comparing statistical data and making inferences from them. So here we will be informally assessing the overlap of different distributions. We'll also be generating random samples to represent populations. With a sample, we can use our understanding of proportional relationships to make predictions about the population it was sampled from. And we can also compare the centers and variabilities of two different samples and make inferences comparing the two populations that they came from. The Unit 5 activity that we'll be covering in this video is the Unit 5 Cumulative Activity. In this activity, we'll be looking at sustainable fishing. In ancient Hawaii, this was not as big of a concern as it is today. Back then, there were many fishing experts who were mindful of balancing the needs of the people with the health of the environment. One way that they were able to maintain this balance was through the use of highly advanced fish ponds called the loko'i'a. These fish ponds trapped the largest fish for easy harvest. At the same time, the loko'i'a also protected the fish from predators and allowed them to grow, both in body size and in population. Today, government agencies such as the Hawaii Department of Land and Natural Resources are needed to protect fish from going extinct. Since the 2000s, this agency has been monitoring papio and the bigger ulua fish. With the help of fishermen, these fish are caught, measured, tagged, and released back into the ocean. By recapturing these fish over time, we can get a ton of information about the health of the papio and the ulua population. In part 1 of this activity, we look at a simple fish survey using the tag and release method. Here we catch 500 papio, tag them, and release them back into the fish pond. At a later date, fishermen caught 100 papio from the same pond. Of the 100, only 10 of them had tags. Please pause the video and use this information to estimate how many papio are in the pond. Okay, so welcome back. To answer this question, we need to first assume that our random sample represents the population that it is taken from, and we need to bring back and apply our knowledge of ratios and proportions. We do not know the total population of the papio, so we'll call it the variable x. What we do know is that of this population, 500 fish are tagged. In our sample, we also know that 100 fish are caught, and of these 100 fish, 10 are tagged. Because we assume that the sample represents the population it is taken from, we can also assume that the ratio of tagged fish to total fish will be the same between the sample and the population it is taken from. So for the population, the ratio of tagged fish to total fish is the fraction 500 over x. For the sample, this ratio is 10 over 100. And these fractions are equals because the sample is supposed to represent the population it came from. So we have that 500 over x equals 10 over 100. Solving for x gives us x equals 5,000. So the population of the papio in this pond is estimated to be about 5,000. Please note that we can also use the reciprocals of both sides of the equations. So x over 500 equals 100 over 10 will be mathematically equivalent and will give us the same answer for x. In parts 3, 4, and 5 of this activity, we'll be comparing the data collected from pairs of fishing spots. Let's take a look at the box and whisker plots of the first pair of fishing spots in part 3. Please pause the video and think about which spot has more large fish, fishing spot A or fishing spot B. Okie dokie, welcome back. Here we can see that the lower quartile of fishing spot A aligns with the upper quartile of fishing spot B. That means that 75% of the fish in fishing spot A are larger than 75% of the fish in fishing spot B. So clearly, fishing spot A has more larger fish than fishing spot B. For this video, we'll skip the last two fishing spot comparisons and jump to the open-ended question at the end. Why do you think it is important to do experiments like these? What can we learn from them, and how can it help to make our world a better place? Please pause this video and think about how you would answer before moving on. As always, we recommend modifying our activities to better fit the needs of your classroom or your teaching style. One area that you might want to focus on is Part 1, where the students are asked to use a sample to make an inference on the population of the fish pond. It can get really confusing when setting up the equations that need to be solved. In our example, we've set it up as 500 over x equals 10 over 100. This is correct, but so is the equation we get when we take the reciprocal of both sides. So x over 500 equals 100 over 10 is also correct and will give us the same answer. However, if we take the reciprocal of just one side, then we have erroneous equations. For example, 500 over x equals 100 over 10 is wrong, and so is x over 500 equals 10 over 100. So we think that it would be hugely beneficial to spend some extra time in this area and to compare the numerators and the denominators. If the numerators of the two ratios describe the same thing and the denominators also match, then the equations should be fine. So in our correct equation, 500 over x equals 10 over 100, the numerators both describe the tagged fish and the denominators both describe the total fish. On the other hand, in an incorrect equation, 500 over x equals 100 over 10, the numerator on the left describes the tagged fish, while the numerator on the right describes the total number of fish. We recommend coming up with your own numbers to allow your students to practice more in this area. Similarly, you can also create more practice opportunities for parts 3 to 5. Here, the students can create box and whisker plots and put their plots into a jar, mix them up, randomly choose two, and analyze them. It will be easy to compare centers when the spreads are similar, and it will be easy to compare spreads when the centers are similar. But when both the centers and the spreads differ, it will be much more difficult to make an analysis. Even though the analysis is difficult, it is really important that the students are given an opportunity to make observations about the distributions and to articulate their findings. Finally, we can modify this activity with a quick sampling activity. With a bag of unknown quantities of marbles, students can introduce marbles of a different color into the bag, take a sample, and try to make an inference about the contents of the bag. That's it for this unit. Please join us for our final video for this curriculum, where we go over Unit 6. Mahalo nui!